increase a bit more cost for the tracker. So here is the SkySmart 2, the tracker here. We haven't put on period models yet because we would like to have this one to be the tracker for installation training. So all the parts can be taken down and put up again. So right now here, what we can see, this orange piece is the motor drive. So you can see the actual motor here in this black encapsulation, and instead having just a motor here, we have two more slew drive on both sides. We will show that later, but you can see the motor drive here not just running the torque tube, this one, but it's also running this square transmission shaft, and this will pass the motion from the motor to the other two slew drives. Let's go again and look at the slew drives. So here is one of the slew drive. So it's about like 20-30 meters away from the motor drive there. So you can see the transmission shaft connect here. So this will simultaneously also rotating the torque tube. And during the high wind speed situation, this will act as like a fixed rod. A fixed point to keep this one, to keep the torque tube stable, fixed. Okay, so as you can see, the distance between these fixed points to the end of the tracker is approximately 10 meters. So this distance is very short compared to the traditional tracker we've just seen. Okay, so for the 2P tracker pulling, you've seen that this one is also very long, but this one doesn't have the support. Yeah. So the difference is we normally use the supports for external tracker because the external tracker normally need to cope with very strong wind speed. But for this particular one, this is an internal tracker, so it does not necessarily need the both like the supports there. Yeah. It will be strong enough, especially with the horizontal stow position. And the other difference is the shape of the torque tube. You can see that this one has the round cornered, unlike the sharp corner. So this structure will help to increase the stability of the torque tube. On the other hand, it will help to reduce some material use.
Okay, so wow. It's pretty impressive out there, isn't it?
Yeah, of course. Yeah. So now we've understand what exactly a multi-drive tracker is, and now let's look at the wind tunnel test profile. So as you can see, initially we for a traditional tracker we have like a reverse V. Have a V. Now this V has been flip up to the top, and for this one, you can easily see that we can safely stow our tracker at 0 degree, and it also helps to extend the operational wind speed.
But this is the multi-drive tracker?
This is for the multi-drive tracker,
okay,
yes.
Right.
Okay. Then the stow wind speed, so what we have achieved is to have our stow wind speed increased from 16 meters per second to up to 20 meters per second.
Wow.
Yeah.
So that's amazing. You completely reversed that V with this multi-drive structure. So now
yes.
Horizontal is, well, it's actually quite advantageous from working too. Like if you're assembling the system, you've got it in one position. You can access both sides of the modules, both sides of the array too.
Sorry, could you rephrase that?
Yeah, sorry. So if you've got your tracker in the horizontal position,
yes,
and you're working underneath it, you can access both sides. You don't have to rotate it to this side, rotate it to this side, and not worry about wind speed. So when it's in this position, if you happen to go for a break, then it's in the stow position already.
Exactly, yes.
That's a pretty complicated explanation, but yeah, I just thought of it from a practical point of view is, putting 120 panels on can take a while. and you probably want to have